Small machines rarely earn respect in the real world, yet these ones broke that rule completely. Each vehicle in this lineup was pushed far beyond its size, built to survive conditions most cars would never face. From frozen landscapes to deep mud and rocky trails, they proved capability isn't about size, it's about engineering intent. If you enjoy real machine breakdowns like this, like the video, share it, and subscribe for more. Number 13. Suzuki Vitara Geo-Tracker. Late 1980s marked a shift in the off-road world, where compact SUVs began replacing heavier truck-based platforms, and Suzuki responded with the Vitara, known in some markets as the Geo-Tracker. Instead of chasing size or brute force, it focused on lightweight construction paired with a true ladder frame foundation that could still handle serious terrain stress. Its compact proportions made it far more usable in urban environments, while still retaining genuine off-road capability when the surface turned rough. The design balanced everyday driving comfort with a mechanical setup capable of handling dirt tracks, sand, and rocky paths without major strain. A small displacement engine delivered modest power, but the lightweight body ensured it never felt underpowered in low-speed terrain work. Short wheelbase geometry improved agility, especially on narrow trails and sharp off-road turns. Four-wheel drive systems were simple, durable, and designed for quick engagement when traction dropped. This made it a practical option for drivers who needed both a commuter vehicle and a weekend off-road machine. Its structure avoided unnecessary complexity, which helped reduce failure points over long-term use. Underneath its small exterior, the Vitara Tracker used a body-on-frame layout that gave it durability closer to traditional trucks than passenger cars. The drivetrain was designed to be straightforward, with part-time four-wheel drive that drivers could engage when needed. This mechanical simplicity made it easy to maintain and repair in a wide range of conditions. Power delivery focused on low-end torque, helping it climb slopes and handle loose terrain more effectively than speed-oriented vehicles. Its suspension system was tuned for both road comfort and off-road articulation, creating a balanced driving experience. Steering remained direct and predictable, allowing control even on unstable surfaces. Fuel efficiency was relatively strong for a 4x4, making it suitable for daily use as well as recreational driving. The chassis was light but reinforced enough to handle repeated off-road stress. Cooling systems and mechanical components were designed to withstand long operating hours without overheating issues. Its simple mechanical layout reduced dependency on specialized service networks. On real terrain, the Suzuki Vitara and Geo-Tracker earned a reputation for being unexpectedly capable, despite their small size and modest power output. They performed well in mud, snow, and light rock conditions, where heavier vehicles often struggled with weight or size restrictions. Many owners use them as dual-purpose vehicles, handling daily commuting during the week and off-road trips on weekends. Their lightweight design made recovery easier when stuck, reducing the risk of being completely immobilized in remote areas. Enthusiasts appreciated their honest driving behavior, where mechanical feedback remained clear and predictable. They became popular in early off-road modification culture due to their strong base platform. Even today, surviving models are valued for their simplicity and dependable performance in rough conditions. Their influence can be seen in later compact SUV designs that prioritized usability over size. Few vehicles in this class managed to combine affordability, capability, and durability so effectively. That consistency earns the Suzuki Vitara Geo-Tracker position 13 in this list of overbuilt mini 4x4 machines. Number 12. Honda Acty 4x4. In the late 1970s, Japan's demand for compact commercial vehicles led Honda to develop the Acty, a micro-utility truck built around efficiency, durability, and extreme space optimization. Rather than scaling down a traditional pickup, Honda engineered it from the ground up as a lightweight work machine for narrow streets, farms, and mountainous regions. Its extremely compact dimensions allowed it to operate in environments where full-size trucks were simply impractical. The mid-engine layout placed the power unit under the floor, improving balance and freeing up usable cargo space. Even with its small footprint, the chassis was designed to handle consistent load stress without structural fatigue. The 4x4 variants introduced additional capability, turning it into a surprisingly competent off-road utility platform. Lightweight construction reduced strain on mechanical components, improving long-term reliability in rough use. Its simple design philosophy kept manufacturing and maintenance costs low, making it accessible for small businesses and farmers. Suspension geometry was tuned for uneven surfaces, allowing it to handle dirt roads and construction sites with ease. Despite its size, it earned a reputation for being tough enough to survive demanding daily workloads. Honda focused on practicality rather than performance, ensuring it remained functional in real working braking conditions. The Acty 4x4 system was engineered to deliver traction without adding unnecessary mechanical complexity to the lightweight platform. Power distribution to all wheels improved grip on slippery surfaces such as mud, gravel, and snow-covered roads. Its compact drivetrain reduced energy loss, helping maintain efficiency even under load. The mid-engine configuration contributed to balanced weight distribution, enhancing stability during cornering and off-road driving. Manual transmission options gave drivers direct control over torque delivery in variable terrain conditions. Steering response remained predictable, which was important for tight urban and rural navigation. The suspension system was designed to absorb shocks from uneven terrain without compromising load capacity. Cooling systems were optimized for continuous low-speed operation, common in utility work environments. Fuel efficiency remained a key advantage compared to larger light trucks. Maintenance procedures were straightforward, allowing repairs to be done quickly in small workshops. In real-world applications, the Honda Acty 4x4 became a trusted vehicle in agriculture, delivery services, construction sites, and mountainous rural regions. Its ability to navigate narrow streets and tight work areas made it especially valuable in densely built or remote environments. Snow and mud performance gave it an edge in seasonal conditions, where traction is critical. Many operators relied on it as a daily workhorse, rather than a secondary or specialized vehicle. Its low operating cost contributed to widespread adoption among small businesses and independent workers. Even older units remain in service due to easy maintenance and strong parts availability. Its reputation grew not from marketing, but from consistent performance in demanding jobs. Enthusiasts appreciate it today for its honest engineering and practical design approach. Few micro trucks have achieved such a balance of size, capability, and reliability. That makes the Honda Acty 4x4 a strong example of compact overbuilt engineering at position 12 in this list of mini 4x4 machines. Number 11. Subaru Brat. The Subaru Brat arrived at the end of the 1970s as an unusual answer to a growing demand for compact, affordable vehicles that could still handle rough terrain and utility work. Instead of following traditional pickup design rules, Subaru built it on a small passenger car platform and added a pickup-style rear bed, creating a hybrid identity. Its lightweight structure immediately sets it apart from heavier trucks, giving it an advantage in agility and fuel efficiency. A key engineering choice was the use of Subaru's symmetrical all-wheel drive system, which delivered consistent traction across all wheels. That AWD setup gave it stability on dirt roads, snow, and gravel, where rear-wheel drive pickups often struggled. The compact boxer engine layout helped lower the center of gravity, improving balance on uneven terrain. Its short wheelbase improved maneuverability in tight rural paths and off-road trails. The suspension was tuned to handle mixed driving conditions, from paved roads to unpaved farm tracks. Despite its small size, it carried a surprising level of structural toughness for its class. It quickly gained attention in markets where versatility mattered more than raw power. The drivetrain system in the Brat played a major role in its reputation, using a permanent-style all-wheel drive layout that improved grip in unstable conditions. Power delivery was balanced across all wheels, reducing wheel slip on loose surfaces like mud and snow. The boxer engine design helped maintain stability by keeping weight distribution low and even. Manual transmission setups gave drivers more direct control over power output in varying terrain. Its mechanical simplicity kept maintenance costs relatively low compared to larger 4x4 trucks. Suspension components were reinforced enough to support light cargo while maintaining comfort on the road. Steering response remained predictable, making it easier to control on uneven ground. The chassis was adapted from Subaru's compact car platform, but strengthened for light utility use. Fuel efficiency was one of its strong points, especially compared to traditional pickup trucks of the era. Its AWD system was more advanced than many competitors at the time, especially in compact vehicle segments. This combination of efficiency and traction made it practical for both urban and rural drivers. It proved that small vehicles could still deliver real, all-weather capability without heavy mechanical complexity. In real-world use, the Subaru Brat found popularity among farmers, outdoor workers, and drivers who needed a compact vehicle that could handle both road and off-road conditions. Its ability to switch between daily driving and light utility work made it a flexible option in rural communities. Snow-covered regions particularly benefited from its AWD system, which provided confidence in winter conditions. Its lightweight body made it easy to maneuver in tight spaces where larger trucks would struggle. Although it was not built for heavy hauling, it performed reliably under moderate load conditions. The vehicle also gained a unique cultural identity in export markets, especially in North America and Australia. Its unusual design and practicality helped it develop a loyal following among enthusiasts over time. Many owners appreciated its simplicity, which made repairs and maintenance straightforward. Even today, surviving models are valued for their reliability and distinctive engineering approach. Number 10. Willys MB Jeep. When World War II demanded a light, all-terrain military vehicle, the Willys MB Jeep emerged as one of the most important engineering responses of its time. It wasn't designed for comfort, luxury, or long-term civilian use, but for survival, mobility, and battlefield efficiency under extreme pressure. Its compact size allowed it to move through narrow trails, damaged roads, and terrain where larger military trucks couldn't operate. A simple body-on-frame structure was chosen to ensure strength without unnecessary weight or complexity. The flat fender design wasn't stylistic, it was functional, helping reduce damage and simplify mass production. Powered by a reliable inline-4 engine, it delivered modest horsepower, but strong low-end torque for rough conditions. Four-wheel drive was permanent, giving soldiers constant traction across mud, sand, and snow. Ground clearance was high enough to handle obstacles, trenches, and uneven battlefield terrain. Every component was designed for rapid repair in field conditions with minimal tools. Its lightweight construction made it easy to transport, recover, and deploy quickly. Military engineers focused entirely on durability and simplicity rather than refinement. The drivetrain of the Willys MB was built to survive continuous abuse in combat environments without failure under stress. A low-range transfer case provided controlled crawling ability over difficult terrain and steep gradients. Its suspension used leaf springs, chosen for strength and predictable load handling under heavy use. The steering system remained purely mechanical, ensuring reliability even when exposed to harsh battlefield conditions. Cooling and engine systems were designed to operate in both desert heat and freezing temperatures. The electrical system was minimal, reducing the risk of failure in wet or damaged environments. Simple gear ratios allowed drivers to focus on movement rather than mechanical management. Maintenance was intentionally straightforward, so soldiers could repair it in the field. Parts interchangeability became a major advantage during wartime logistics operations. Its drivetrain layout influenced countless future off-road and military vehicles. Despite its simplicity, it delivered consistent performance under extreme operational stress. In actual wartime conditions, the Willys MB proved itself across multiple theaters, including Europe, Africa, and the Pacific. It became essential for reconnaissance, troop movement, medical evacuation, and supply transport under fire. Its ability to keep moving in mud, rubble, and destroyed infrastructure gave Allied forces a major mobility advantage. Soldiers trusted it because it rarely failed when properly maintained in harsh environments. Its lightweight frame allowed it to be airdropped or transported with relative ease. After the war, surplus units quickly entered civilian use, especially in farming and construction. This transition helped shape the entire civilian off-road vehicle market that followed. Many design elements later evolved into modern SUVs and utility 4x4 platforms. Collectors and historians still recognize it as one of the most important vehicles ever built. Its influence extends far beyond its production years, shaping decades of automotive design. It remains a symbol of practical engineering, built under extreme wartime demands. That is why the Willys MB Jeep owns position 10 in this list of overbuilt mini 4x4 machines. Number 9. AMC Eagle SX4. When American Motors introduced the Eagle SX4 in 1980, it didn't follow the usual path of rugged trucks or traditional off-road SUVs. Instead, it took a compact coupe-style body and paired it with full-time all-wheel drive, creating something completely unusual for its time. The concept came from combining passenger car comfort with genuine off-road traction capability, not just occasional bad weather assistance. Its raised ride height immediately separated it from standard compact cars, giving it a more utility-focused stance. Underneath, the system used a robust drivetrain derived from AMC's larger Eagle platform, built for continuous power delivery. The suspension was reinforced to handle uneven terrain without compromising too much on-road stability. Unlike many small AWD systems of the era, it was designed for constant engagement rather than manual switching. That meant the vehicle could adapt instantly to changing surfaces like snow, gravel, and mud. Its compact size allowed it to retain agility while still offering surprising all-terrain confidence. The SX4 body style gave it a sporty appearance, but its engineering focus was far more functional than cosmetic. That combination made it stand out in a market that wasn't ready for such a hybrid concept. The drivetrain system in the Eagle SX4 was built around AMC's full-time all-wheel drive architecture, which constantly distributed power to all four wheels. This system removed the need for driver input when transitioning transitioning between road and off-road surfaces. A central differential allowed smooth power balance between front and rear axles under varying grip conditions. Its suspension setup was strengthened to cope with both highway comfort and rough terrain durability. Engine options were tuned more for torque, delivery, and reliability than outright performance figures. The chassis reinforcement helped reduce flex during off-road stress, improving long-term durability. Steering remained car-like but stable, allowing predictable control even on loose ground. The braking system was designed to handle mixed-use conditions without overheating quickly under load. Fuel consumption was higher than that of basic compact cars, but justified by its added capability. Maintenance was more complex than simple economy vehicles, but still manageable for most workshops. Its mechanical layout was ahead of its time for a small all-weather vehicle. On the road and off it, the AMC Eagle SX4 proved that compact coupes could survive in conditions normally reserved for trucks and larger 4x4s. It handled snow-covered roads particularly well, which made it popular in colder regions of North America. Drivers appreciated that it didn't require switching modes or adapting driving habits when conditions changed suddenly. Its elevated ride height helped it clear rough rural roads and unpaved paths with less risk of damage. Despite its sporty shape, it became a practical choice for users who needed year-round reliability in harsh weather. It also served as an early inspiration for later crossover-style vehicles that dominate today's market. Many owners valued its combination of passenger comfort and unexpected off-road confidence. While not a hardcore rock crawler, it consistently outperformed expectations for its size class. Its unique identity helped it build a cult following after production ended in 1988. Surviving examples are now appreciated for their originality and engineering boldness. That originality earns the AMC Eagle SX4 position 9 in this list of overbuilt mini 4x4 machines. Number 8. Fiat Panda 4x4. A simple city car was never expected to become one of the most capable lightweight off-road machines in Europe. Yet the Fiat Panda 4x4 changed that perception completely when it arrived in 1983. Instead of building a large SUV, engineers took the original Panda and added a compact four-wheel drive system designed specifically for rural and mountain regions. Its lightweight structure became its biggest advantage, allowing it to move across snow and mud, where heavier vehicles would immediately struggle. The body design stayed extremely simple, keeping weight low and mechanical complexity under control. A small but effective engine delivered just enough torque to push the car through difficult terrain without overwhelming its compact drivetrain. Ground clearance was increased compared to the standard model, giving it better ability to clear uneven rural roads, allowing better wheel contact on rough surfaces. The 4x4 system used a basic mechanical layout, making it reliable in remote areas with limited service support. Its short wheelbase helped it navigate tight mountain paths and narrow village roads with ease. Even though it looked like a normal hatchback, its behavior off-road was far more serious than its appearance suggested. It became especially popular in alpine regions where snow performance mattered more than size or power. The four-wheel drive system in the Panda 4x4, durable and easy to maintain, rather than technologically advanced. Power distribution was mechanical, ensuring consistent traction without relying on complex electronic controls. Its lightweight drivetrain reduced stress on components, improving long-term reliability in harsh conditions. The engine output remained modest, but low-speed torque delivery made it effective on steep and slippery terrain. Steering stayed direct and unassisted in early versions, giving drivers clear feedback on loose surfaces. Suspension travel was optimized to keep all four wheels engaged with the ground as much as possible. The compact chassis helped reduce body roll and maintain balance on uneven slopes. Fuel efficiency remained strong even with the added 4x4 hardware, making it practical for daily use. Maintenance was straightforward, allowing repairs to be done in small rural workshops. It avoided unnecessary complexity, which helped it survive in regions with limited infrastructure. In real-world conditions, the Panda 4x4 proved its value. In environments that punish larger and more expensive SUVs, it became a trusted vehicle in mountainous villages, farming regions, and snowy landscapes where traction is more important than power. Its low weight allowed it to float over soft surfaces instead of sinking like heavier vehicles. Many drivers used it as a daily commuter, as well as a seasonal off-road tool, especially in winter conditions. Its ability to handle steep climbs and icy roads made it a practical solution rather than a novelty. Over the decades, it has built a strong reputation for reliability in Europe's most demanding rural areas. Even older generations remain in service due to simple mechanics aerodynamics, and easy part availability. Off-road enthusiasts respect it for its honesty and predictable behavior in difficult terrain. It is often underestimated because of its size, but it repeatedly proves itself when conditions turn extreme. Few small vehicles manage to combine affordability, simplicity, and real off-road ability so effectively. That consistency secures the Fiat Panda 4x4 at position 8 in this list of overbuilt mini 4x4 machines. Number 7. Lada Niva. Born in the Soviet Union during a time when durability mattered more than comfort, the Lada Niva was created as a practical answer to harsh geography and limited infrastructure. Instead of copying Western SUV trends, engineers designed it as a compact 4x4 with permanent all-wheel drive from the start. Its unibody construction was unusual for off-road vehicles of its era, yet it delivered surprising strength when paired with a simple mechanical layout. The goal was not luxury or speed, but consistent mobility across frozen plains, muddy roads, and mountainous regions. A fully independent front suspension improved handling on rough terrain compared to many rigid axle competitors of the time. Its short wheelbase gave it strong agility, especially in tight forest paths and narrow rural routes. Ground clearance was deliberately high to reduce the risk of underbody damage in uneven landscapes. The engine was modest, but tuned for low-end pulling ability rather than highway performance. Mechanical systems were intentionally kept basic to ensure repairability in remote Soviet regions. This made it a vehicle that could be fixed with minimal tools and limited spare parts. From the beginning, it was engineered as a survival tool rather than a comfort-focused car. That purpose-driven design is what gave it long-term staying power. Permanent four-wheel drive became one of the defining features of the Niva, setting it apart from many competitors that required manual engagement. Its transfer case distributed power continuously, improving traction across unpredictable surfaces. The suspension setup combined independent front geometry with a solid rear axle for durability under load. This mix allowed it to maintain stability while still adapting to uneven ground conditions. Steering was kept mechanical and direct, giving drivers clear feedback on rough terrain. The drivetrain was built to tolerate long-term stress without complex electronic assistance. Engine options were simple but reliable, focusing on consistent torque delivery. Fuel consumption remained moderate, making it practical for daily use in rural regions. The compact body helped it move through narrow paths where larger SUVs could not fit. Maintenance was straightforward, which was essential in areas with limited service infrastructure. Over time, small refinements improved comfort slightly, without changing its rugged identity. Its engineering balance made it effective in both civilian and utility roles. Across decades of production, the Lada Niva proved itself in some of the harshest environments on Earth, from Siberian snowfields to muddy agricultural zones. It became widely used not just by civilians, but also by government and utility services, needing dependable off-road mobility. Its ability to keep moving in extreme cold conditions made it especially valuable in northern regions. Despite its simple construction, it consistently outperformed expectations for vehicles in its class. Many units remained in service far beyond their expected lifespan due to ease of repair and part availability. Its lightweight structure helped it avoid becoming stuck in soft or unstable terrain. Even modern versions retain the same basic architecture, showing how effective the original design was. Off-road enthusiasts respect it for its mechanical honesty and predictable behavior under stress. It is often modified, but even stock versions are capable of serious terrain work. Its reputation was built through decades of real-world use, rather than marketing claims. Few compact 4x4s have maintained relevance across such a long production history. That lasting capability earns the Lada Niva position 7 in this list of overbuilt mini 4x4 machines. Number 6. Renault 4 Sinpa. An ordinary economy hatchback was pushed far beyond its original purpose when engineers adapted it for rough terrain use. Instead of creating a new platform, Renault modified the Renault 4 into a light utility vehicle with off-road capability. The Sinpa conversion added four-wheel drive functionality without changing the car's simple foundation. This turned a basic commuter vehicle into something capable of handling farms, forest tracks, and rural paths. Its extremely low weight became a major advantage on soft or unstable ground. Suspension travel was limited, but effective enough to deal with uneven terrain. Small increases in ground clearance improved its ability to cross dirt and muddy roads. Mechanical design stayed simple, so repairs could be done in remote locations. Even after conversion, it kept the efficiency and low running cost of the original model. The drivetrain upgrade improved traction without adding unnecessary complexity. It became a practical solution where infrastructure and service support were limited. That simplicity is what kept it useful in harsh rural environments for decades. The SynPar system allowed power to be distributed to both axles when extra grip was needed. This worked with the original layout without requiring a full redesign of the vehicle. Light construction reduced stress on mechanical parts during mixed road and off-road use. Instead of electronics, it relied on direct mechanical engagement for traction control. Engine output was modest but suitable for low-speed utility work. Steering remained predictable, helping drivers control the vehicle on loose surfaces. Durability of suspension parts was important due to constant rough terrain exposure. Compact size allowed access to narrow rural roads and tight working areas. Fuel consumption stayed low even after the drivetrain modification. Maintenance was simple enough for basic workshop repairs in rural regions. It filled the gap between a normal car and a light off-road utility vehicle. This balance of simplicity and capability made it unusually effective for its class. In practical use, it proved effective in agriculture, forestry, and rural transport tasks. Snow, mud, and gravel conditions highlighted its ability to stay mobile where others failed. Many users relied on it as a single vehicle for both daily driving and light off-road work. Its lightweight structure made recovery easier when stuck in difficult terrain. Long service life came from simple construction and easy maintenance. It became a dependable tool for small businesses operating outside major cities. Balanced weight distribution helped maintain stability even when carrying loads. Its long production run showed steady demand from practical users. Collectors value it today for its unusual combination of simplicity and capability. It represents a rare transformation from an economy car to a functional off-road machine. That's why it holds position 6 in this list of overbuilt mini 4x4 machines. Even today, it stands as proof that minimal engineering changes can unlock serious utility. Number 5. Suzuki Jimny. The Jimny wasn't designed to look powerful. It was designed to function in places where normal vehicles fail immediately. Its compact size hides serious engineering intent, focused on survival rather than comfort or appearance. A rigid ladder frame structure gives it durability usually found in much larger off-road machines. Instead of increasing size for comfort, Suzuki kept it compact so it could move through tight and unstable terrain. That short wheelbase improves maneuverability on narrow and uneven paths. Early models removed unnecessary features to focus only on movement, traction, and reliability. Even the engine choice prioritizes low-end torque over high-speed performance. Solid axle construction helps maintain wheel contact on unpredictable ground. Every design decision supports one goal: keep moving when conditions get difficult. It gained trust in regions where road infrastructure is unreliable or completely absent. Its reputation was built through performance in real environments, not marketing claims. That simplicity is exactly what makes it survive, where complex vehicles fail. Through multiple generations, Suzuki refined the Jimny without changing its core identity. Instead of turning it into a comfort SUV, improvements focused on traction and durability. The four-wheel drive system was upgraded to handle sudden changes in surface grip. A compact transfer case keeps mechanical control simple and predictable. Suspension tuning allows strong wheel articulation on uneven terrain. Steering remains mechanical to avoid complexity that could fail in remote areas. Engine updates improved efficiency while keeping torque delivery as the priority. Despite modernization, Suzuki avoided unnecessary size or weight increases. This keeps it effective in forests, mountains, and narrow rural paths. Maintenance remained simple enough for basic field repairs. It became widely used in agriculture, expeditions, and utility services worldwide. Its design philosophy stayed untouched, even as technology evolved around it. The Jimny proves itself in environments that punish both driver and machine without warning. It performs well in terrain where heavier SUVs lose traction due to excess weight. Its lightweight body helps it stay mobile on soft ground instead of sinking. Off-road users value it for control and predictability under stress. In many regions, it serves as a daily working vehicle rather than a lifestyle product. Its mechanical simplicity allows drivers to understand its behavior without electronic interference. Even in modern markets, it stands out because of its straightforward engineering. Different generations still share the same identity: compact size with real capability. Its long service life shows the strength of its original design philosophy. Few vehicles in its class remain relevant across so many terrains and decades. That consistency earns it a position 5 in this list of overbuilt mini 4x4 machines. It remains one of the clearest examples of how less complexity can create more capability. Number 4. First-gen Toyota pickup. Originating in post-war Japan, Toyota developed its early pickup line as a practical utility solution during national reconstruction efforts, starting in 1947 with evolving models that eventually shaped the first-generation pickup identity. The design philosophy focused heavily on durability, simplicity, and the ability to operate in underdeveloped infrastructure conditions. Unlike refined consumer vehicles, it was engineered to survive constant heavy use in farming, construction, and rural transport roles. Its ladder frame structure provided a strong base capable of handling repeated payload stress without major deformation. Engine options in early production were modest but tuned for torque delivery rather than speed or refinement. The suspension system was built using leaf springs, prioritizing load support over comfort. Ground clearance was intentionally generous to handle unpaved roads and rough terrain. Its body design was straightforward, reducing manufacturing complexity and improving repairability in the field. Mechanical systems were intentionally kept simple to ensure long-term reliability in harsh environments. The vehicle quickly became essential for commercial and agricultural users across Japan and export markets. It established Toyota's early reputation for building extremely durable utility vehicles. This foundation made it a strong example of overbuilt practicality in its era. As development progressed through the early decades, Toyota continuously refined the pickup platform to improve strength and operational endurance. The drivetrain was engineered to handle continuous heavy-duty use without frequent mechanical failure. Manual transmissions were designed with durability in mind, allowing consistent performance under load. Rear-wheel drive configuration was standard, providing predictable handling for work-oriented applications. Cooling systems were strengthened to maintain engine stability during long working hours. Steering components were built with robust mechanical linkages rather than complex systems. The frame was reinforced to withstand twisting forces encountered on uneven rural terrain. Brake systems were basic but reliable, ensuring consistent stopping power under load conditions. Maintenance accessibility was a key design focus, enabling quick repairs in remote areas. Many components were standardized to simplify replacement and servicing. This engineering approach made it highly dependable in developing infrastructure environments. Its mechanical resilience became a defining trait across all early Toyota pickups. In real-world use, the first-generation Toyota pickup became a backbone vehicle for agriculture, small industry, and transportation in both domestic and international markets. Its ability to operate under continuous load made it extremely valuable in regions with limited mechanical support infrastructure. The truck gained a reputation for surviving conditions that quickly disabled more complex vehicles. Its long service life in many countries demonstrated the strength of its engineering philosophy. Export success helped establish Toyota as a global manufacturer of reliable utility vehicles. Many units remained in operation for decades due to their simple and repairable design. Its chassis durability allowed it to be repurposed for multiple roles beyond standard pickup duties. Operators trusted it because downtime was minimal even under harsh working schedules. It influenced later Toyota pickup generations that continued to focus on durability over luxury. Collectors and restorers still value it for its historical significance and mechanical honesty. It stands as a clear example of overbuilt utility engineering from an early automotive era. That is why it earns the 4th position in this list of extreme Mini 4x4 machines. Number 3. Volkswagen Iltis. Developed by Volkswagen for military requirements in the late 1970s, the Iltis was introduced in 1978 as a lightweight tactical off-road vehicle built for extreme operational environments. It was designed to replace older utility platforms with a more modern, agile, and mechanically efficient 4x4 system. Unlike heavier military trucks, the Iltis focused on mobility, simplicity, and durability under harsh battlefield conditions. Its construction emphasized a lightweight body to improve speed and maneuverability across uneven terrain. The vehicle used a proven Volkswagen inline engine configuration adapted for low-end torque and reliability. A full-time four-wheel drive system ensured constant traction across mud, sand, and snow conditions. The suspension setup allowed consistent wheel contact even when terrain shifted rapidly. Engineers prioritized mechanical robustness over luxury or comfort features. Its compact design made it highly suitable for reconnaissance and rapid response missions. The chassis was engineered to handle repeated stress cycles without structural fatigue. Military testing confirmed its strong performance in cold weather and desert deployments. This combination of lightweight and rugged engineering made it stand out in its class. The drivetrain system of the Iltis was built around mechanical simplicity to ensure reliability in field operations. It featured a manual transmission that allowed precise control in low-speed tactical movement. Torque distribution was optimized for consistent consistent traction across all four wheels. The vehicle's suspension geometry supported high articulation over rocky and uneven terrain. Its steering system was designed for predictable handling in both high and low speed conditions. Cooling systems were engineered to maintain stability during extended off-road operations. Electrical systems were kept minimal to reduce failure points in combat environments. Maintenance could be performed quickly using basic tools, even in remote locations. The body structure was resistant to corrosion and environmental wear over time. Its compact wheelbase improved turning radius for confined terrain navigation. The Iltis demonstrated strong performance during NATO field evaluations in multiple climates. This reinforced its reputation as a dependable military mobility platform. Operationally, the Volkswagen Iltis was widely used by several European armed forces during the 1980s for reconnaissance, communications, and light transport duties. It became especially known for its participation in extreme cold weather testing, where many competing vehicles failed to perform consistently. Its reliability in harsh conditions made it a preferred choice for rapid deployment missions. The vehicle's lightweight structure allowed it to be air transported with relative ease. In competitive evaluations, it outperformed several heavier and more complex 4x4 systems. Its engineering philosophy influenced later developments in compact military mobility vehicles. Production continued until 1988, after which more modern platforms replaced it in service roles. Despite this, surplus units remained in operational use for many years afterward. Enthusiasts still value it for its raw mechanical character and off-road capability. It represents Volkswagen's serious entry into military-grade engineering during that era. The Iltis remains a strong example of efficient overbuilt design in a lightweight package. That is why it earns a third position in this lineup of extreme mini 4x4 machines. Number 2. Willys Jeep FC150. Produced by Willys Overland, the FC150, introduced in 1956, was built on a radically different design philosophy compared to traditional utility 4x4s. Instead of placing the engine in front with a long hood, engineers moved the cab forward over the front axle for maximum cargo space efficiency. This layout created a compact footprint while still delivering serious off-road capability derived from Jeep's proven drivetrain systems. Its short wheelbase made it highly maneuverable in tight industrial, farm, and construction environments. The chassis was heavily reinforced to handle payload stress, despite its small size class. Four-wheel drive capability came from the same rugged mechanical heritage used in earlier military Jeep platforms. Ground clearance was optimized to allow it to crawl over uneven terrain without major obstruction. The suspension system was simple, but extremely durable under continuous load conditions. Its body-on-frame construction ensured long-term structural reliability in rough service. Operators valued it because it could work in spaces where larger trucks physically could not operate. This combination of compact size and durability made it unusually capable for its era. It quickly gained a reputation as a small truck with big truck strength. Mechanically, the FC150 used a proven inline-4 engine known for low-end torque rather than high-speed performance. This made it suitable for hauling and crawling tasks rather than highway travel. The drivetrain was paired with a manual transmission designed for simplicity and field repairability. Power delivery was intentionally conservative to prioritize reliability over output figures. Its transfer case allowed smooth switching between two-wheel and four-wheel drive modes. The steering system was basic but effective for precise low-speed control in confined areas. Cooling and mechanical systems were engineered to withstand long operational hours under load. Unlike modern compact trucks, it avoided unnecessary complexity that could reduce field reliability. Maintenance requirements were minimal, allowing owners to service it without specialized tools. Its mechanical layout made it popular in remote job sites and rural industries. Even under heavy use, it maintained consistent performance without frequent breakdowns. This simplicity was one of its strongest engineering advantages. In real-world use, the FC150 became a trusted workhorse in agriculture, forestry, and industrial logistics operations. Its compact size allowed it to access narrow paths, tight yards, and confined work zones where larger vehicles failed. Despite its small dimensions, it could handle surprisingly heavy payloads due to its reinforced chassis design. Many units were adapted for snow plowing, utility work, and maintenance roles in difficult environments. Its durability allowed it to remain in service for decades in some regions without major redesign. The design influenced later compact utility trucks that followed similar forward control layouts. Drivers appreciated its visibility and control, especially in low-speed operational tasks. Its mechanical reliability made it a preferred choice for organizations that needed consistent uptime. Even today, restored versions are valued by collectors and off-road enthusiasts. It represents an era where engineering focused on function rather than comfort or aesthetics. The FC150 remains a strong example of overbuilt compact utility engineering. That is why it earns the second position in this list of extreme mini 4x4 machines. Number 1. Pinzgauer 710. Built by Steyr Daimler Puch in Austria, the Pinzgauer 710 was designed with one goal: survive terrain that destroys normal 4x4 vehicles. It entered production in 1971 and quickly became a specialist platform for military and rescue operations across harsh regions. Instead of a traditional ladder frame, it used a central tubular chassis, giving it extreme torsional strength under load. This design choice made it far more resistant to twisting damage on rocky and uneven ground. Its engine placement and drivetrain layout were engineered for balance rather than speed or comfort. Portal axles were installed to raise ground clearance significantly above standard off-road trucks. Independent suspension on all wheels allowed unmatched articulation over obstacles. Even when multiple wheels lost grip, the system maintained forward mobility. The structure was built to tolerate stress levels that would disable conventional 4x4s. Every mechanical element was prioritized for field reliability instead of cost efficiency. This made it a trusted vehicle in extreme military logistics environments. From the start, it was clearly designed to be overbuilt rather than simply functional. Power delivery in the Pinzgauer 710 was focused on low-speed torque instead of highway performance. Its drivetrain was engineered to distribute traction evenly across all wheels under pressure. Early versions used air-cooled engine technology to reduce dependency on fragile cooling systems. This allowed operation in freezing climates where liquid cooling could fail. The transmission system was reinforced to handle continuous off-road strain without overheating quickly. Steering geometry was tuned for precision control in narrow mountain and forest routes. Suspension travel was unusually long for a vehicle of its size class. This gave it the ability to climb, descend, and traverse uneven terrain without losing stability. Maintenance was simplified, so repairs could be performed in field conditions. Military crews could keep it operational without advanced workshop support. Its engineering focus clearly favored endurance over comfort or speed. This made it highly dependable in long-term deployment scenarios. Throughout its service life, the Pinzgauer 710 was adopted by multiple armed forces and emergency organizations worldwide. It proved especially valuable in reconnaissance, supply transport, and evacuation missions in remote regions. Even after sustaining structural damage, many units remained operational due to their robust chassis design. Field reports consistently highlighted its ability to continue moving in conditions that immobilized other vehicles. Its modular construction allowed damaged components to be replaced quickly in operational zones. The vehicle performed reliably in deserts, alpine zones, and muddy terrains without major redesign. Its reputation was built on real-world endurance rather than theoretical specifications. Surplus units continue to be used today by expedition teams and rescue operators. It is still studied in off-road engineering discussions as a benchmark of durability. Its legacy is defined by resilience, mechanical simplicity, and extreme terrain capability. This is why it earns its place as the first entry in any overbuilt mini 4x4 list. What you've just seen isn't a list of vehicles. It's a timeline of compact machines that refuse to stay limited. Every entry proved that smart design can outperform brute size when conditions get extreme. From military legends to small utility icons, each one earned its place through real-world survival, not marketing. If you enjoyed this video, like, share, and subscribe. More deep mechanical stories are coming next.